Good morning. Okay, we're going to get started here. I don't expect this to be a long session today. Just going to talk about a few things. Basically, just going over Newton's 3 laws, because that's going to pertain to the assignments that'll be posted. We've talked a lot about what a force is, types of forces, and let's move into Newton's law, and then we'll kind of go back and pull it all together. Say hi to Harold, by the way. Hi, Raquel. Thank you for joining. And so the first, this is a little bit of a review because we touched on some of this before. What inertia is. Inertia, my old joke was that I used to call my dog Inertia because she didn't want to move. But inertia is the tendency for something to stay in the state that it already exists, whether that's in motion or whether that is completely staying still. I had my props up here, but if I took this roll of tape, I can use anything, and threw it, inertia says, this is 8th grade, 7th grade is at 11, 6th grade is at 12, so 10, 11, 12, 8, 7, 6. Anyways, let's see who else. If you come in the room and you're supposed to be here, say hi. I see 6 people, and 2 said hi and 1 said bye. If you are supposed to be here, this is 8th grade science. If you are supposed to be here, please say hello so that we know you're in the room. 7th grade is at 11. 12th grade is at noon. It's been the same for the past 4 weeks. 10th grade is at, 8th grade is at 10, 7th grade is at 11, 6th grade is at 12. By the way, this is going to be how we do school for the rest of the year. The state just announced yesterday. Kind of sucks because I really miss going to school. Hi, Elijah. Joey, good. Glad to see you guys coming in. Thanks for saying hi, so that we can acknowledge that you're here, because that's going to pay off. You know, when you're sitting in class, you get a participation grade, and so just showing up for the lecture is going to help you too. You guys will have some stuff loaded up onto Google Classroom today or tomorrow. It's taken me a long time I'm finding I'm having to spend some time manipulating documents to get them loaded up and get them the way I want them. We're so used to doing things with paper in the classroom. By the way, I'm really I keep getting distracted because there's a robin who's putting the final touches on its nest right outside my windows here. This room has windows all the way around, and it keeps flying across, bringing in some twigs and mud for the nest. It's so cute. So So let's get back to what I was talking about. We're going to talk about try to get through Newton's 3 laws today and talk about what inertia is. And like I was saying, if I took this piece of tape and I threw it, inertia says that it's going to keep going in the direction that I throw it. If I throw it as hard as I can, it's just going to keep going whatever direction I throw it. If it's sitting here in my hand, then inertia also says it has a tendency to do nothing or not change. It's going to continue to exist in whatever state it is. And so that is basically Newton's first law. It's called the law of the law of inertia. An object in motion will stay in motion unless it's acted upon by an outside force. So if I throw this, it's going to keep going unless it's acted upon by another force, which is going to be gravity, right? Gravity is going to keep that ball or this roll of tape from keeping going straight. It's going to pull it down to the ground. Gravity is a pull, not a push. The other thing that's acting upon it is fluid resistance, and we'll talk about that a little bit more in detail, but the air itself is going to slow this down from going as fast as it will. So the air is acting upon it, which is called fluid resistance, and gravity is pulling it to the ground. So it's going to keep going unless something else is acting on it. So an object in motion will stay in motion unless acted upon by an outside force. The opposite is true too. An object at rest will stay at rest unless it's acted upon by an outside force. So probably 2/3 of the 8th grade class right now is suffering from inertia. What do you mean, Mr. Soriani? You're probably in bed sleeping just like my teenage daughter is right now. All right, so the suffering from inertia. So an object in motion will stay in motion, an object at rest will stay at rest unless acted upon by an outside force. That's called the law of inertia. And an object is not going to move unless it's acted upon, or it's not going to stop moving in the direction it's going unless acted upon. If you think about that, if there's a piece of space rock that's just comes from deep space and comes into our solar system, it's coming in at a direct path. Let's say that this is Earth. It comes in at a direct path. Well, guess what? Earth's gravity is going to pull it. It might not pull it into Earth, but it'll pull it enough that it'll change its direction. Instead of being in that straight line, that gravity is going to act upon it, that space rock, and change its trajectory once it passes the Earth. So gravity can act on something even in outer space. It could be the sun that will act on something and pull it and change its trajectory. By the way, as we go around the sun each year, our trajectory is never identical to the previous one. It always changes a little bit. All right, so that's number one. Number two is the acceleration of an object depends on the mass of the object and the amount of force applied. So there's actually a formula for that. And it is F equals m times a. Anybody know what those F, M, and A might be? I just kind of set it. And where am I? I had something pulled up here. Now I won't be able to find it. By the way, you can change. A lot of times, forces or formulas are interchangeable. Those of you guys who know math know that you can change a formula in various forms. Okay, so that being said, force equals mass times acceleration. Acceleration equals force divided by mass, or mass equals force divided by acceleration. What that means is if I have any of those two variables, if I know what the force is, and remember force is measured in newtons, mass might be measured in grams, kilograms, and then acceleration is usually measured in miles per second, feet per second, kilometers per second. So if I have any of that information, it just becomes a simple math form. And I know you're in 8th grade, all you guys can do multiplication or division, and that's all those three are. If I give you a worksheet with that, it's going to have the formulas on the top of the worksheet. Your job is to decide what is a force, what is a mass, and what is acceleration. So a force will always be measured in newtons. Force will always be measured in newtons, and I just posted it up there. So you can, the idea behind that, and I have this kind of big old steel plate here. Now I have my plate and I have my cell phone, okay? And I'm gonna kind of push this down, the camera down towards the table so you can see it for a second. But the whole point is how much force is needed to push this cell phone compared to how much force is needed to push this steel. And so I'm going to put this down for a second here. Okay, so you can see my cell phone here and my steel plate. Now I can take this with my little pinky and hit it, and it moved about 2 inches. I do that with this, the same amount of force, and it's not moving at all. Okay, so what has changed in that formula is the mass of these two objects. This has a lot of mass. This has a lot of mass. It's a steel plate. And my cell phone, you guys know how light cell phones are, does not have a lot of mass. And so in that formula, force equals mass times acceleration. If I'm using the same amount of force to push something, but it has more mass, then, hey Malachi, then it's either not going to move at all, or it's going to require more force to move. If you think about, you guys have all hopefully ridden bikes. If you've ridden a bike, you know it's pretty easy to pedal, right? But if any of you, I got to be honest, this has been me. As you get older, you guys start getting cars and stuff. Chances are at some point in your life, you're going to run out of gas. I can get on a bike and pedal a bike, but if I run out of gas, I can't push my car by myself. If I can, it's because I've got a real small car, like a Volkswagen Beetle or a, what's the British one? A Cooper, Mini Cooper. Most of the time, you need a couple people to push a vehicle because the mass is so great. So Newton's second law is pretty simple. The acceleration of an object depends on the mass of the object and the amount of force applied. So if we keep a steady force on something, we can increase speed with it once we get it moving, especially if it's on wheels. But the biggest factor really is its mass, whether it's something, and this is it's only twice as big, but it's probably about 7 or 8 times as heavy. And I do come across a lot of strange things that I'll say, oh, I can use that in science class, just some simple little thing that we can use as an example. And so that's Newton's second law. And so you will be getting an assignment that basically it's basically mostly math, but it's understanding which is which. What don't I have? If I have force and I have mass, then I need to find out what the acceleration is. If I have acceleration and I have mass, then I need to find out what the force is. So it's just simple math. I say simple because it's multiplication and division. You guys should be able to get that. Look at something for a second. All right, so that's Newton's second law. First law, object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an outside force. Newton's second law, the acceleration of an object depends on its mass and the amount of force that you apply. That's cool. That's understandable. We can talk about some real life. I just talked about like trying to push a car that's run out of gas. One guy can't do it. You get 2 or 3 guys, maybe even 4 guys, depending on what size vehicle it is. Then you can roll it out of the street or into a gas station or whatever you need to do with it. Newton's third law, so the last thing we'll go over. For every action, there is an equal and opposite reaction. Okay? I like to think about baseball. And I had a baseball in here somewhere, and it's gone. That's because my grandson was over. But let's assume that this drumstick was a baseball bat. And I go to swing at a pitch. I would say I'm pretty likely to hit it. I don't know if we all could say that. Love you guys, but I know some of your strengths is not athleticism, more brain power, right? So let's say we come around and we hit a ball, okay? Let's say this eye from my iPhone is the actual ball that I'm going to hit. That ball's coming in, this bat's coming around, okay? And when you think about it, you think, well, that ball's going to go out to the outfield, okay? So, but there actually is a reaction on the baseball bat, in this case, the drumstick. When I hit that, by me hitting that, there actually is a bounce back of sorts. If I hit the table with the drumstick, it actually does do just what I'm saying. It actually bounces back. And so there is an opposite reaction to everything that we do. And so you don't see it when you're swinging a bat because it's so minute or small that we have a hard time measuring it. But as you're hitting that ball, it will actually have a reaction to the bat. Not only is these are coming together, remember, and so you would think if this is going 350 feet, then is this bat coming back? Maybe, maybe not. What usually happens is it slows the bat down. So if this bat was coming around with a serious velocity and it hits a ball coming in, it might only slow the velocity of the bat down. So if it's traveling at I don't know, 1 meter per second, by hitting this ball, that might slow that down slightly. Okay, so for every action, there's an equal and opposite reaction. I'm going to see if I can post a couple videos online or have them ready for you guys on Thursday to look at with Newton's third law. If we do something stupid, like get mad and punch a wall, we're going to hit the wall and our hand is going to bounce back, especially if it's a brick wall or a plaster wall. And we're going to pay the price for that and really be in pain. And so it's really important that we don't do anything stupid, but really important that you understand anytime you hit something, it's actually bouncing back too. Might not see it, it might only really appear to be slowing something down, but for every action, there's an equal and opposite reaction. I like to think that that's true in life, right? If we do something stupid, usually somebody does something stupid back to us. All right, so does anybody, yeah, a rubber wall would be kind of bouncy, wouldn't it? But there still would be a reaction. I like that idea because if you actually hit a rubber wall, right, you can actually see that rubber wall will take some of that blunt force, right? That rubber wall is going to go like this. And then what is it going to do? It's actually going to, I can't make my hand go that way. It's actually going to come back the other way and push whatever it got hit with back the other way. Think about a trampoline. Trampoline's a great example. You guys have all gone to, been on a trampoline or in a bouncy house or gone to Sky, whatever that place is called, Sky Air. I keep getting distracted by my little bird buddy here. You're on a trampoline, you jump, pushes it down. That's the action. What's the reaction? Throws you back up in the air. You do your little gymnastic somersault and a little ta-da at the end, and you're happy. So that's a really good example. Thanks for bringing that up. I think that was Elijah. Thanks for bringing that up and the rubber wall, because it made me think about trampolines, since I had wanted to talk about that, where you have that bounce, boom, and you come back. We are out of time because somebody else is broadcasting, but those are Newton's 3 laws. Understand this is how we're doing school for the rest of the year, according to the governor as of yesterday. Make sure you're logging on to get some instruction. Tuesdays and Thursdays at 10 a.m. Thank you guys for joining. And Google Classroom, make sure you're getting on Google Classroom. There's some people who have not submitted any documents. You can email me, and here it is. You guys, you guys should know my email by now, but and you can access it through Google Classroom. You can just send me a message and it goes right to my email. I try to answer emails pretty much from 7 in the morning till about 10 or 11 at night. I appreciate you guys that are working, doing hard work and asking me questions. Don't be afraid to. Good to see you, Brianna. I have a lot of students that are sending me private messages saying, hey, I don't understand this. And that's great. That's fine. I want to be able to help you guys out. This is not just about getting a grade. This is about filling our minds with knowledge that we can use. All right. And I'm going to give you an example on Thursday of how Newton's third law can be dangerous. And my word for the day is axe. That's not when you ask a question. That's what you use to chop wood. Have a good day. Say goodbye to Harold.